Hello. In this presentation, I will talk about the findings of the technical review that was published as the deliverable 2.1 of Accord project. This technical review examines the existing ontologies, standards, and data models in the architecture, engineering, and construction domain, and explore how they can be reused for the purpose of automatic compliance checking. The exploration of these ontologies and standards is achieved through exploring the resources from the Open Zotero library of the project. The study made in this review evaluates the construction domain-related ontologies and proposed suggestions on how they can be employed for the development of the architecture, engineering, and construction compliance checking and permitting ontology. It also compares the rule languages developed or used in the AEC projects, as well as the existing reasoners that could be useful to build in permitting automatic compliance checking. The findings of this technical review will serve us as a reference for other tasks within the project, which will determine which ontologies can be reused, aligned, or serve as inspiration for the creation of the compliance checking ontology to be developed in task 2.2 of the second work package. It also will determine the preferred rule languages that can be used in other tasks of the project, such as task 2.3 and task 2.5. The fourth work package will also benefit from the description of various existing reasoners and rule engines. Furthermore, the standards that are presented in this deliverable can be employed in various aspects of the Accord project, like the tasks in the second and the fourth work package. I will talk next about the encountered issues in this study, the ontology classification, the metrics and assessment of ontologies, before concluding this presentation. In our review, we have identified several key issues. The first one concerns the number of domain ontologies. There are many ontologies within the construction field, and we don't know which of these are relevant to the Accord project. We also need to assess the work done by various working groups, organizations, and projects in the construction field. It is also essential to evaluate these ontologies based on special criteria. And finally, there is no single ontology that can fully meet our needs. So the main question is, how can we present the existing domain ontologies used in the construction field with a detailed explanation of their characteristics? According to the study we conducted on building ontologies, we propose to classify them according to the application domain and according to their characteristics. We detected 4 areas of applications: building environment modeling, building compliance, regulations, and building permit modeling. And the second classification we propose is based on the ontology characteristics such as building element, building permitting, IoT, construction safety, quality control, and regulations. This diagram shows the classification of 46 ontologies by domain and characteristics. We notice that some ontologies belong to several domains, like the Building Assessment Ontology, BAO, which was used as Building Compliance Ontology, and an ontology of regulations. We also notice ontologies with different characteristics, like IFCO, for example, which is used to represent building elements like products and also represents IoT sensors. To assess the richness of ontologies, we use metrics that use statistical measures as well as quality control measures. The statistical measures describe the number of classes, individuals, and properties, as well as the maximum depth, the highest and the average number of children. That could be either subclasses or subproperties. On the other hand, the quality control and assurance metrics focus on the number of classes with only one subclass, classes with more than 25 subclasses, and classes lacking the definition. We have found that some ontologies are very rich in concepts and individuals, like the brick ontology that describes 1,452 classes and 2,566 individuals. RCO ontology also contains 1,326 classes and 1,162 individuals. However, other ontologies contain fewer individuals and fewer classes, like the European Legislation Identifier ontology, ELI, that only describes 33 classes and contains 28 individuals. The unit ontology also, QUDT, contains only 31 classes. This difference is explained by the nature of the data represented by the ontologies. We evaluated the quality of each ontology using evaluation tools that use different metrics. The first tool scores each of the four fair axes. The second tool, called Ontology Pitfall Scanner, identifies the presence of bad practices and warnings in the ontology. And the third one, OQUER, scores a set of evaluated characteristics in an ontology. After performing evaluations using these methodologies for each ontology, the results indicate their commendable performance, making them suitable candidates for implementation in the context of Accord projects. Now I will show some evaluation results. For example, the brick ontology that contains a semantic description of the building, its characteristics, and its components, has obtained good scores according to OQUER metrics. The brick ontology also obtained good scores according to the principles of FAIR, except for the reuse principle, which evaluates the richness of the ontology with metadata, descriptions, license, developers' information, etc. The brick ontology evaluation with Ontology Pitfall Scanner revealed some alerts with different severities, like the cases where there are some missing annotations, but some of these warnings are more severe than others according to the tool, like the missing domain or range in some properties. As a conclusion, we have analyzed ontologies related to construction, BIM, and regulations for the Accord project in order to enable the implementation of automatic compliance checking. According to our study of existing ontologies, none of the existing ontologies link the physical description of buildings, which may include its spatial characteristics, design, elements, etc., with regulations, which may include the description of legislation, legal resources, safety regulations, etc. So no ontology can be used alone to conclude on the building's compliance based on its semantic description. Hence the need to create an ontology containing the building description and the rules to be applied for semantic reasoning tasks. The findings from this study could provide valuable information for Accord and assist in selecting relevant ontologies for building compliance checking or general building modeling. Thank you. Here is a list of Accord project partners.